Hi everyone! Today's lecture will cover a topic of special importance for new space, that is the deployment and exploitation of information networks in space. Today we will explore the subject matter with an expert in this field, Joan Ruiz de Azua from the Nanosatellite Laboratory of the Universitat Politècnica de Catalunya, UPC. Joan and I will also talk about some exciting work we've done together between UPC and Skoltech in flying a prototype of a satellite network in the stratosphere over Moscow. We had an opportunity to do so in the context of the systems engineering class I teach at Skoltech, with the flight sponsored by the Skoltech Space Center, which we sincerely thank for their support. In fact, Joan and I and other collaborators had a space telecommunications adventure together when we decided to make a flight demonstration of federated technology flying and recovering balloon payloads in the middle of nowhere outside of Moscow. And this was the result.
Yes! We catch the signal!
If you want to know more about space networks and why we ended up demonstrating federated systems in the Russian countryside, follow us through the rest of this video. Hola Joan, thank you for joining us today.
Hola Alessandro, thank you for inviting me. It is a great pleasure to be here with all of you and talk about this interesting topic that we have been investigating indeed in our laboratory.
Joan, if we look back at the history of satellite missions, we see that the majority of them, especially in the first decades of the space era, were actually monolithic missions, right? Since the 1980s, we have been talking about satellite constellations and later on about other ways of connecting satellites together. The discussion on satellite networks has been around already for a long time. Why are satellite networks needed currently? What do you think?
This is a really good question that researchers have tried to answer during the last years. Everything starts from the user needs. As you, Alessandro, commented in the new space video series, among others, there are other two big communities in the new space, the Earth observation and the telecommunication. Both sectors has been evolving during the last years, demanding new services and applications. For instance, the Earth observation community is requesting the deployment of systems that can monitor different areas using instruments with high spatial resolution. In the telecommunication sector, the satellites are becoming more important to deploy a global infrastructure that enables communication between remote users. Indeed, it is currently being discussed how to integrate satellites in the 5G and Internet of Things infrastructure.
Very interesting. Yeah, I agree 5G will be a big topic in the near future. We even hear of 6G already in space research, right? What do you think are the key requirements for designing a satellite constellation?
From my point of view, due to these new scenarios, the needs of the user have changed. These new needs impact on the requirements for constellations. We can summarize them in 5 features: low revisit time, high downlink capability, fast access to the generated data, low communication latency, and finally, high availability. Having those requirements in mind, we design a satellite constellation accordingly. For instance, we start to define the number of orbit planes, satellites per plane, and other constellation parameters. After that, the resulting constellation is analyzed to verify that it can satisfy the user needs. Following this traditional design process, surely the result constellation would be composed of a lot of satellites. Why this magnitude? Because the current user needs are really demanding. The question here is that if this big constellation is feasible. Note that deploying those satellites could be really challenging. For instance, you have to coordinate and pay the launch, then in-orbit maintenance and operations, frequency filling, and so on and so forth. It is not trivial to deploy this constellation. We have to evaluate the problem from another perspective. If we assume that satellites can communicate between them, the constellation design and its performance change. For instance, we can improve the downlink capacity of our constellation if a satellite can download data over another satellite just after being generated. These new inter-satellite communication capabilities would enable the optimization and improvement of current satellite systems. Moreover, it changes the traditional concept of the space, starting to conceive it as satellites connected between them, composing satellite networks.
Sounds exciting, Joan. As you know, we have many different types of protocols, topologies, and architectures for networks of information systems on Earth. What type of satellite networks exist up there in orbit?
The concept of a satellite network has been discussed during a large amount of years. Professor Werner started evaluating the concept of satellite network in 1997. The different connections or links between nodes in a network are typically represented in network topology. Take a look at this chart as an example of the topology representation for a network on the ground, with computers and devices. Professor Werner had liked that the node links in the topology of a satellite network change over time, remaining stable during a lapse of time. These stable moments represent snapshots of the topology, which can be ordered sequentially over time. Making a parallelism, it is like a video, which is composed of an ordered sequence of frames. Satellite network is thus considered as a discrete time network, having a fixed topology at each interval. This chart here shows an example of a sequence composed of 3 snapshots. Note that each snapshot is generated due to the change of the nodes 4 and 5 connections. Why does this behavior appear? It is due to the satellite motion. Satellites are nodes that are constantly moving, following the orbit trajectory. This motion makes that the distance between the satellite changes over time, becoming sometimes closer and other time further. Let's consider 2 satellites that are moving at a certain moment become really close. At this moment, the communication link between them is feasible. After a while, they start to moving away, breaking this link. The 4 links are feasible during a lapse of time, and consequently, each snapshot. There is, however, a feature on the satellite motion that helps. Satellites follow periodic trajectories. For that reason, a snapshot sequence is always periodic, repeating after a while the same initial topology. However, this feature does not always simplify the sequence, because its periods depend on the number of satellites in the network. More satellites, large periods. If you are interested on this snapshot concept and you want to go deeper, I totally encourage to read Professor Werner's work. You can find an important reference just below. These changes on the topology make satellite network really dynamic. For that reason, it is not easy to establish satellite connections between remote satellites or ground devices. Therefore, some researchers have conceived specific system architectures to mitigate this dynamism.
Interesting. What type of approaches do you see? Can you make some examples maybe?
Well, for example, the virtual node architecture proposed by Professor Eikichi presented a low Earth orbit satellite constellation, placing the satellites in a specific location. Let's take a look at this chart. On the left side, it is presented the LEO constellation architecture, in which the ensemble of satellites composes a network mesh, as you can see on the right side. With this specific architecture, each satellite has always 4 links to its adjacent satellites, baptized by Professor Eikichi as intersatellite links. Satellites in this configuration move simultaneously, following a coordinated choreography, which keeps the intersatellite link fixed. It is easy in this mesh to define any possible route between 2 remote satellites, jumping over rows and columns. This approach, however, is not perfect, and it has some peculiarities that ensure the mesh structure. As you can see in the previous chart, a seam separates the satellites that move in the opposite directions, forbidding any possible intersatellite link. Additionally, this mesh network cannot be maintained in the poles, because the distance between the satellites becomes really small. For that reason, the communications in the polar zone is also forbidden. You can see this situation presented as a red line in the plot. This LEO satellite constellation concept has been already implemented in the space. It is the case of Iridium Next constellation. This chart close to me shows the constellation with the mesh topology. If you are interested in this kind of network, you can find more information in this reference that appears below. Another approach to mitigate the satellite motion was also proposed by Professor Eikichi, using multiple satellite constellations in different altitudes. In particular, the multi-layered satellite network defines a satellite network as a hierarchical structure composed of satellite systems placed in different altitudes.
All right. Multi-layer networks, that sounds interesting and new. Can you tell us a little bit more about them? They sound like a very different concept of network. We're used to thinking at satellite constellation at something that is at a certain orbital altitude and that is communicating to the ground, right? Multi-layer networks are different. How can you manage such a network operating at different layers and orbital altitudes?
Okay, let me explain. To manage a multi-layered network in space, each higher layer satellite covers a set of lower layer satellites, using its larger footprint. This chart makes the point clear. In this example, a geostationary satellite manages the connection of the medium Earth orbit satellites, that it sees. Consequently, each MEO satellite does exactly the same with the LEO satellites. It exists thus this hierarchy between the layers, having a more global view the higher ones. Note also that these higher nodes can be used to relay data from lower satellites, and in the end, this hierarchical structure makes the satellite network more organized.
Can you make us concrete examples of multi-layer space networks that have been proposed or that are flying in space already?
Sure. Nowadays, there are people talking about using GEO satellites to relay data from LEO satellites. This plot clarifies the concept. This is indeed the example of multi-layer satellite network. Formally, there exist two missions or projects to deploy this kind of system. The European Data Relay System proposed by ESA and the Traken Data Relay Satellite System from NASA. Part of the national space agencies, private companies have started to be relevant in this field. It is the case of SpaceX that wants to deploy the Starlink constellation. This LEO satellite constellation follows the strategy that we presented at the very beginning, deploying thousands of satellites. This satellite system is known as mega constellations and are characterized by having also inter-satellite links. With this configuration, they aim at providing internet coverage to the whole globe. Let's see a fragment of this SpaceX video. The performance of the constellation that you can see on the top right corner competes with the current ground performance. However, as we have said before, this new architectures implies a lot of technological, legal, and managing challenges, so not everybody will be able to deploy these mega constellations.
Okay, together with Joan Adria, today we have reviewed the state of the art in space internetworking as it has been proposed in the literature over the last few years. In the next video, we're going to talk about flight demonstrations on space internetworking that Joan and myself, our teams at UPC and Skoltech have been working together and flying stratospheric balloons over the Moscow region. Stay tuned next week to see the continuation of this topic. Thank you very much.